The video of the power supply I'm building for my electronic project. There's a big transformer there, bridge rectifiers, capacitors for smoothing, and another bridge rectifier that I've built myself with a thing I believe is a 6 amp diode. These are 1500 microfarads for 6 volts. They're rated at about 25 volts. And these are 4700 for they're rated at 35 volts, and this gives me 18 volts. And these are 5800s, 56 volt, and that rail gives me 35 volts. And the rectified electricity comes here and up to the second part of the power supply, where it's got the LM723s regulators. There's one circuit here and there's one circuit here, and because these regulators they don't produce that much amperage, you can't really run anything from them, so you need to have a transistor arrays like this, Darlingtons I have, to boost up the amperage so you can use it for at least something. This bit gives me up to 6 amp, and this one gives me, I think it's different transistors, so this one gives me I think up to 3 amps. There's the output here and the output here after these two resistors. I have to wire them properly. I haven't wired them yet, just done the initial test and everything runs fine. This is a variable regulator, LM317T. I believe it's 1.2 amp can handle, but I got 2 transistors here, PNP transistors, power transistors, so they boost the amperage up to I think about 3 amp, 2.5 to 3 amps. I'm not going to be really needing that much power from these ones. These are going to be mainly for running I don't know, 555s, CMOS, general stuff. It comes to this switch, activate it, turns it on, because I don't want it to be, everything will be running at the same time. I can turn them on and off. These pot resistors, I can set the voltages, 3 of them, and then I can quickly jump to any voltage I want by pressing these buttons. Say if I want 3 volt, I turn this one on, then the rest are off, so that gives me 3 volt on output. I'll turn this off and turn this one on, gives me 12 volt, and the other one I think gives me 11 or 10 volts, but I can adjust them anything from 1.2 to I believe is 17 volt, because whatever you feed them takes away 2 volts and feeds you regulated on that side. So this is 19 volts, so you give me about 16.5 to 17 volts. This is the second bit I've done. These are the fixed regulators. It's the 7805, 7807, 7809 and 7812. So it's a 5 volt, 7 volt, 9 volt and a 12 volts. They're rated at 1 amp, but what I've done is I put 2 transistors here, power transistors, and connected to them wire resistors, and they bring up the amperage up to 3 amp on any of them. Because I couldn't run their output, I couldn't just connect all the outputs together and then run it through the transistor. I have to run it through its diode, and I didn't have any power diode, so what I used these kind of half bridge rectifiers. They're 2 diodes with a common output, so you feed it 2, then it coming out. I got 1 here and 1 there. I got them from a switching power supply, from computer power supply that I salvaged. And these 2, 5 and 7 come through here, 9 and 12 through here, this one, and then they're connected via resistor, and the voltage can be selected via this switch. I can select if it's here, so it's 5, I can go 1 up, 5, and then 7 and so on, 7, 9, 12 and so on. The last 2 I haven't used anything. I'm probably going to put dual rated power supply as well. So what I can do, I can run the minus I believe I have minus 8 somewhere, 79 I think it's 7908 and 7912, so it's minus 12 and minus 9. I don't have any space here. I believe I can might be able to push this to the side and just make a little circuit here and run it here. I won't need a big thing like this for the miners. I'm just going to be using it to run op amps and comparators and things like that, and they're not going to be using that much power, so I believe just the normal 1 amp will be fine for them for everyday jobs anyway. There's going to be a cover on top of this, like so. Will come on top of this, and I'm going to build a little front panel for here. And I'm going to be having 2 of these little cheap ass multimeters, and I'm going to be connecting them here just to check the amperage, so I'm always safe. I know what what is going on. These one got short circuit and under voltage and under current protection, these 2, and the other fixed regulators are short protected, and so is this one, so they won't blow up if you get short circuited. I'm just going to make a front panel, put these 2 on the top. I just need these 2 for the high powers and the fixed regulator, and I have a little voltmeters. I have these that I can they measure from I believe it's from 7 to 30 volts, and I'm gonna have 3 or 4 of them here. I haven't really designed the front panel yet properly, so I don't know what's going to be on the front. There's going to be a switch to turn the load on and off, and a switch to turn individual parts on and off, because I don't want them to be on. As I've measured, they don't use anything. I mean, when they turn them on, they don't use any amperage or any voltage. They don't cause stress on the transformer. So I thought I'd just put a safety switch and turn them off, and when I need them I can just turn it on. That's going to be that, and this one is going to be a switch on it, and as you can see at the back there, there's a little transformer and a relay. That's always on when you press the main power on. That comes on, and with this I can gives me 5 volt at the back output to run the relay, and with that I can put a switch here and turn the main transformer on and off. So if something goes wrong, I'll quickly turn it off and everything goes off, like a safety switch or something. And what I need to do, I need to put a fan here on the top, down here somewhere, computer fan, because I was running 5 amp from this for about 15 minutes, and it's got very hot, and I don't like it get that hot, so I'm going to put a fan to just keep things cool inside. And I bought the boxes from Maplin at quite a reasonable price. I think it was £9 each. I'm going to buy another box that goes on top of this, and that's going to be having a high voltage DC, which are the boosts that I've built. This is one of them. This is the boost circuit that I've built. You put 15 volt here, and you get roughly about 250 volt out of here. It's quite a bit of dangerous kit. I got electrocuted a couple of times on it, and I use it to just test anything. I can't test transformers and stuff because it's a DC, it's not AC. If you connect it to transformer, it just makes the transformer go hot and then just burn the magnet wires. I can bring the voltage down. I can control the voltage with this. I get anything from roughly about 70 volt to about 250 volt at 15 volt. I can't go more than 15 volt because it's a 555 chip and it will blow up. It's fast switching transistor, inductor, capacitor, and some filters and what's so on. That's one of them, and this is another one I've built. Same kind of principle, but the frequency is less, and the way it's done with the transistors, inductors that I've made myself, and diodes. And this got three rails, and each rail gives me at about 60 volt. And I've rated them up to, if I use 1 amp, they come to the voltage drop from 60 to about 48, 47 at 1 amp, which is not bad. I can use it for turning relays on and off, and maybe to run stepper motors. I haven't tested it. I don't know how much amperage they use and stuff, but it's going to be on the third part of the power supply that I'm building, and that's going to be on top here, the third section. I might put a fan here at the bottom as well, a small fan at the back maybe, and the front panel here are perforated so air can flow through it. There are little holes here that air can be sucked in, some here as well, some there, and some at the bottom. I might put something on the bottom of this to elevate this a little bit up, and that's it. So this is the part 1. I couldn't really film the making of the beds that I have, these beds, because my camera was playing around. I bought this new phone, so I'm just recording it with my phone at the moment. But I will video the rest of the project that I'm going through, and I will post it, and see you go from there. And these are some of the parts that I have that I use for my project. These are the TTL ICs, CMOS ICs, op-amp, PICs, Atmels, microcontrollers. I have lots of inductors, transformers, regulators, and this bit is the IC sockets, LEDs, 7-segment displays, power diodes, power transistors, regulators, pots, more transistors, SMT stuff, capacitors, diodes, Zener diodes, inductors, more inductors, more inductors, more inductors, filters, inverters, power resistors, lots and lots of capacitors and filters again, ceramic capacitors, infrared, lasers, crystals, timers, more capacitors, electrolytic, ceramic, LEDs, lots of LEDs, high density ones, different colors, diodes, more Zener diodes, relays, switches, and here I have resistors, all sorts of resistors here. I've got switches, heat sinks, and connectors, and drill bits, and the rest of the stuff. These are some of the stuff I have. This is my trusty old power supply that I use. It's a very good power supply, I bought it from Maplin. Only problem is it's got one output, so yeah, if I put it, say, for 10 volt or 12 volt, I'm doing something, I can't really change it anymore to do something else. So what I used to do before is quickly make up a little regulator on this breadboard and do the rest of the test on it, but it wasn't really good. I had to every time do it, so I decided to build this little sucker to do all the stuff that I want to do. So I had the transformer salvage from old amplifier. Sorry, not amplifier. Old, yeah, it was an amplifier actually. It was a Sony amplifier. Home